Hello, everyone. Today, I would like to compare TAZI's continuous learning technology with the traditional batch machine learning models. Continuous machine learning by TAZI provides self-maintaining and continuously running models that can sense and adapt to any change in the environment. The models update themselves at every instance and never stop learning. On the other hand, traditional batch machine learning models such as Python XGBoost have the possibility to degrade significantly over time since they are not maintained or updated continuously. It takes weeks to adapt to a change in the working environment, and the loss in the business value could be huge as the environment changes. If you have any applications in production that utilize batch machine learning, you probably know how much effort and time it takes to prepare the new data sets, update the models, and redeploy them into production. Let me actually show you a better way, which is TAZI's continuous ML. For the purposes of this demo, I've used the publicly available bank marketing dataset where the data is related to direct marketing campaigns by phone calls from a Portuguese banking institution. The goal is to predict if the client will actually subscribe to a term deposit or not after the marketing call. So let's actually deep dive into this dataset. If you look at the dataset, there's a concept drift. What that means is the count of yes instances, meaning the count of successful term deposit subscriptions, increases over time. So this dataset is ordered from May 2008 to November 2010. And as you can see, there's a significant change in the environment that increases the number of yes instances. And this change could be a major change in the banking environment or a modification in the marketing campaign of the institution. This concept drift can also be explained with the target distribution in the first 50% and last 50% of the data, where in the first 50%, we observe a 4.5% yes ratio, whereas in the last 50%, there's a 17% yes inside the dataset. So this problem is actually a great example to showcase the continuous learning of TAZI, because there's a significant change in the environment, and the machine learning models need to adapt to such a change. So let's go and see how the continuous learning model and batch machine learning model behaves inside production. Here, you see the accuracy of the models throughout time where the model started to train at instance 0 up until where they actually went into production. However, as you can see, after the batch machine learning model went into production, because of the change in environment, the batch model starts to degrade in terms of performance. Whereas TAZI's continuous learning technology keeps training itself on an instance-by-instance basis and keeps increasing its accuracy and adapts to that environment. As you can see, there's a 50% difference in terms of accuracy at the end. So, what this actually means in terms of business value is that if you would have used batch machine learning, wrong calls to hundreds of people that were unlikely to purchase the term deposits would have been made. Whereas if you would have actually used TAZI's continuous learning, your marketing campaign would have been a huge success. Thank you. Please reach us at info@tazi.ai or visit us at www.tazi.ai. TAZI, the next generation AI.